invited to join us now. You will see the products a little bit later. Good afternoon. My name is Ank Chabalala. I'm the Director of Indigenous Knowledge-Based Tech Innovation Unit of the Department of Science, Technology and Innovation. This session is looking into the future. We're going to talk about areas such as green nano biotechnology, nuclear medicine, artificial intelligence, precision agriculture, robotics, machine learning, and areas of science such as that. But we'll be looking into these areas in relation to indigenous knowledge-based technology innovation. So on this panel, we have some of the leading scientists in our midst. And I think the way we'll do this is to start off by allowing each one of them to introduce themselves and where they're coming from, but also then respond to the first question. I think given the time, we'll have only 2 questions to deal with. The first question will be, how do they view the role of indigenous knowledge systems within the context of their fields, their respective fields, and what it is that they are doing currently in terms of indigenous knowledge systems as it relates to their respective fields in emerging sciences, and of course today, artificial intelligence and the related fields. The panel that we have today, we have Professor Khabumwa Khanedi, Professor Moses Cho, Dr. Lutendo Matomu, Professor Bukosi Maribate, Professor Vinesh Maharaj, and Professor Abraham Madier. Let's give them a hand. So as I said, we'll then start with yourself, Prof. Mkhanedi. You'll introduce yourself and then share how do you see your emerging sciences field of biotechnology, molecular biology, and how it relates to indigenous knowledge systems, and briefly share what it is that you do at your university. Thank you so much. You may go ahead.
Tobela Lekai. My name is Khabo Moganedi. I am a professor in microbiology in the Department of Biochemistry, Microbiology and Biotechnology at the University of Limpopo. And I also serve as the IKS coordinator in the university. And my other task is also to revive the biotechnology strategy of the university. I must say I met IKS some 15 years ago when I started a project on Marula wine. Most would know me for the Marula wine, but that's not why we're here. The current strategy that we're developing for biotechnology in the university, we're looking into big data, working with big data. And that will require the use of the AI pipeline in terms of the analysis, the handling, and the interpretation of knowledge. And looking at what we have actually amassed, the amount of information that actually exists, the historical data, and also some that we are busy generating now with what we do. We normally, when we look at the conventional way of doing research, normally you would look at one plant and then you have your own treatment and you get one output. So the big data allows us, and this is really where the future is going. This allows us to actually look at, we generate a big data because that is the technology that we have now. The tools that we have, the RDI tools that we have, allows us to generate big data, and that allows us to actually, in terms of the analysis, we can actually look at the IKS, look at the kind of responses that it elicits. If I can give an example of medicinal plant research, that normally when you treat because you'll be looking at diseases, you'll be looking at pathogens. So if you look at that, you find that you're actually just looking at the responses. So, but we're working with big data. It allows, especially when you look at cellular level. I don't want to be too technical because the audience is varied. So that allows us to actually look at a new, look at the, what do you call it? The mode of action, the mechanism of action of the indigenous plant resources, but it also gives an opportunity it gives more information where you can actually find new drug targets. So that is where we're going in terms of the kind of research that we're doing. And we also, I'm leading the microbial fermentation team in the department. And that actually, with the new technology that we have, you can actually use precision fermentation, and it allows you to predict, to have model prediction, and that will allow us, all of us, to actually produce different types of products. You have predictions, and when you go to the lab, it takes away the amount of time that you spend in the lab in terms of trial and error. So from the raw material getting to the product, the amount of time is actually reduced because it takes away the trial and error phase where you spend a lot of time, sometimes missing the heat. So that is what we actually reinventing ourselves and repurposing the biotechnology strategy in the university. And we do have capabilities, we do have the capacity, so the only thing that is missing may be the tools now, but with the little tools that we have managed to make some strength, and we are confident, and that gives us confidence in the path that we're taking as the university. So we have the expertise in bioinformatics, we have the expertise in machine learning. And I must say, as I indicated, the research that we have a very large group in biochemistry and biotechnology that are looking at communicable and non-communicable diseases. And we also have the new startup also in biorefineries. So I must say, yes, the future is looking bright with the technology if we do get the right support and also the kind of infrastructure that we need.
Yeah. Do you think, before you pass it on, do you think with the capabilities that you have as a university currently, maybe even as a province, do you think that the university and the province are ready to use the capabilities that you have to industrialize?
Yes. Let me give you an example. We have just finished a study, just completed a PhD study now, which was looking at medicinal plants, what we call medicinal plants, and also TB treatment. And these are the medicines that are used in, these are the trees that are mostly used in traditional medicine to treat respiratory ailments. And we use this high throughput technology. From that data that we generated, limiting, even though there is limiting, we are limited in terms of the analytical tools. But with that data that we generated, it actually demonstrated that the mode of action of how, the pathogen, your TB strain, and how it will actually evade the pressure from the treatment. So it shows, even now in terms of drug development, it actually shows that it can validate the traditional knowledge, but it also gives opportunities for new products and this is what we're doing manually. You can think if we do have large data set and the tools that can assist us. So I must say that we're ready for that. It's just that, yes, the tools that are needed, we should get support on that.
Prof. Mariwat, recently you have been the face of artificial intelligence in the country, and I think an order of congratulations is due from this house that you were awarded the order of Mapungubwe. I think it's a hand for Professor. From the presidency, so we are happy to have you here. Now, in your space, big data, that's what you use as a substrate to do your work. But listening to what you had today and yesterday, how do you see artificial intelligence and the work that you do supporting the endeavors that we have, especially in relation to industrialization? How can we use artificial intelligence to support all those small, medium enterprises at the back for them to ultimately industrialize? Thank you.
Okay. Inkomo, Nhlakani. Yes, thanks for the invitation. I felt a bit like the odd one out. I got this invitation, but thank you for having me here. So I'm at the University of Pretoria. I'm the director of the African Institute for Data Science and AI, AfriDSAI, based there at the university, the chair of data science, and a professor of computer science at the university. I'm a co-founder of an AI company called Lelapa AI. And a lot of the work that I do personally in terms of research, it's at the intersection of artificial intelligence or natural language processing and African languages. So when I was invited here or asked the first time in thinking about this and thinking about indigenous knowledge systems, I was very concerned about definitions. Why is that sometimes, you think people just use words, but words have meaning. It's a very important thing. So in the work that we do, a lot of it is on how do we model or how do we represent African languages in these AI systems. The AI systems can be large. The system people are now, when they think about AI, they're thinking about these chatbots or these large language models, but they can also be very small. They don't need to also be AI. It can be other ways that you're doing things like translation, summarization, transcription. That is something that is for a lot of people might improve access, that you can speak and then a machine in whichever language that you choose to use, that it can accurately write down what it is that you were speaking about. These are the things that we're working towards. Sure, in South Africa, we might have 12 official languages, but we have many, many more that are used and spoken. And across the African continent, we have 2,000 to 3,000 languages. Some of them are written, some of them are not. Some of them have different scripts. And as such, this gives a very rich tapestry of how knowledge is transmitted. And that's why I said I wanted to be careful about definitions, of saying now, for us in the work that we do, we straddle two areas. So on one, as we're building these tools, we are hoping that the scholars who are now working to preserve or to document or to unlock our indigenous knowledge can use them in their areas, because now they can find people where they are. You are now not forced to translate. You are not forced to put things in another language that then loses meaning. And through that, we hope that preservation will go on. On the other side, in terms of thriving, we hope languages continue being used in communication, in sharing ideas, in forming new ideas, and as such, it might not be fit the more traditional, some of the definitions of IKS, because we're saying, no, it's now. We're building systems that allow people to continue, not necessarily look at the knowledge where it might be embedded, but seeing how new knowledge gets created as well. And that's what we're trying to do. As an example, last year we led a project to collect 3,000 hours of speech data and transcribe it, and then from there build reference models that can then transcribe in 7 South African languages, right? To do this is, one part is Herculean. If you think about in building this model, so what happens in machine learning, a machine learns from a pattern from your data. So you must give it data of the audio, so somebody speaking, and you must also give it data of the transcript, what actually they said. And then the model learns from the audio. So to do it, at the moment it seems more than 100 hours is required with a big model to be able to represent some part of that language. So the reason we did 3,000 hours, which was 500 hours for a few languages, and 250 hours for Isindebele and Chivenda, is to enable people to be able to build these systems. And what we're hoping as this year goes on, you will see somebody saying, no, now our system supports Chivenda. Our system supports you speaking in Isindebele. So you release the data, you release the references, and then people then are able to build and continue building on those spaces. Now the interesting part comes in when you now think about preservation, cultural understanding, all the topics that come inside IKS. How then can we connect that? And the reason I said yes to coming here is I'm hoping to start that fire to say the tools are becoming available. How do we challenge people like Vukosi and say, how do we use them in IKS?
Thank you so much for that. Someone said, Ankh, just give me one country, one developed country, which teaches its children in a foreign language. And I struggled, and I couldn't find anyone. So the work that you're doing is very essential because we call this work interfacing. And the interfacing happens in our children, in our students. Now, the concern that I'll also pass to the other colleagues here is there is this concern that if AI learns all these things, it may run away with our knowledge, with our information, especially with indigenous knowledge systems. How do you see us creating models where we'll now start using our own languages to then say, this medicine does 1, 2, 3, without then AI misappropriating this and then sharing it with other countries where they can even synthesize molecules of medicines? How do we protect ourselves from that?
Sure. I'm going to keep it short because I think we have a big panel and we want to go through the questions. And I think one is more why we need to think about the governance of AI is very important. And part of that is not just simply the AI or the models, but it's the data, it's the interfaces with humans, and all of those things. And that's why we need the full society to be part of the development. It is not something to be left and said like, no, it's going to be the researchers, the academics, or the private sector. Everybody is part of these systems. There are things on how do you use IP, copyright, in a way that then protects knowledge, even with open, being that you can be equitable. You can open up knowledge in specific ways that still have reserved the rights to say, I only allow you to use this in this way and not in that way. Only if you're doing it for public benefit, not if you're using it for commercial purposes and all of those things. And these are parts of the discussions we're even having in a lot of the work that's happening on artificial intelligence across the whole African continent. It's a very important thing because we don't want people to think that they must hide their knowledge because they are worried. That there are tools. We have people, for example, at the University of Pretoria, the Data Science Law Lab with Prof. Chijoko Kori, CIPIT at Strathmore University in Kenya. They are working on building these licenses that can allow people to, when their data that they create, the content, they can be licensed appropriately. Yeah.
Wonderful. Thank you so much. Professor Maharaj, you in our consortium, you are maybe one of the first that is having all these type of machines that I don't understand. Now, if we link what Prof. Mokhanedi and Prof. Maribate said, how do you then use the work that they do in terms of big data, but in this case, in terms of artificial intelligence, and coming up with this blockbuster that you always say, we just need one blockbuster. How do we then use this knowledge to come up with a blockbuster? What are you doing at the university, which we can then say we have this one blockbuster which we can industrialize?
Okay, good afternoon, colleagues. So I actually wear two hats. I'm the acting dean of the Faculty of Natural and Agricultural Sciences. And just to let you know, an important initiative that we have at the university in terms of transformation is curriculum development. And IKS has become one of the important pillars of actually how do you incorporate IKS as part of curriculum transformation, including the work because he's talking about is the language models, using that as part of the curriculum transformation as well. But my other role is actually I have a center called the Biodiscovery Center, which was funded by the DST, which I'm very grateful for. And as Ang says, it has lots of machines, maybe high-tech equipment, robotic equipment. And the main objective of that is to be able to identify new ingredients, mainly pharmaceuticals or drugs that can be used for treatment of these various diseases, especially those prevalent to Africa. So the approach you've probably already heard about is that everyone works at some stage on a medicinal plant with some traditional knowledge and then tries to come up with a product or an ingredient that actually, through all the research from biological testing and chemistry, and come up with a new drug or pharmaceutical. So that approach is very tedious, and you've all heard how long it takes and the challenges around it. So we've actually changed the approach slightly and said, well, let's go for numbers, and let's go for thousands of samples rather than one at a time or a few at a time, because often only every 10,000 medicines that are researched, only one gets to the market. So we have 10,000 plants that we actually put in through this machinery of high throughput technologies of high throughput screening, and we catalog all of that and then also go through the process of trying to develop a new and identify new ingredients. But that is also very costly. So at the interface of artificial intelligence and let's say IKS, so it's like an old ancient knowledge system and a new knowledge system, and how do you merge these two? And at the start of AI, and when it actually came around, we said, oh, how can we incorporate these two? And then we realized that a lot of information that we all do on medicinal plants, including the indigenous knowledge and the biological data and chemistry, is all published. Thousands and thousands and thousands of paper. And we also have a lot of data in-house as well on all the plants we've done. And that's when we said, well, why can't you use AI or machine learning to mine that data, to actually write targeted algorithms to actually look for a disease, target diseases, target the plants, target the knowledge, and actually get the machine to select which ones are probably the best candidates. And we've actually started with one of those, and one of them is in malaria. So it's actually proving to be quite successful in terms of being able to do that. So that's just the start of it, but I think that's going to grow. And so at one point in time, we'll should have a model where you put in your name of your plants, all your knowledge, and you should make a prediction on what's the probability of this being good for a disease, including all the data. So that's the model that we're currently developing and working on. But then I thought a bit more in terms of traditional healing and IKS. How can this be of use to traditional healers? And then we looked into basically the classification of medicinal plants and classification of medicines as traditional healers would do it. And you realize that a lot of classification is based on temperature classification, so hot, cold, water, sweet, all that is used actually, the classification of plants is used to treat people. And traditional healers know that. But of course, I'm talking English, right? Bukesi will tell you, if you just translate all of that into the knowledge of what traditional healers would know, they will understand it better. So why not use AI with exactly the same data that we have, all the pharmacology data, all the chemistry data, all the descriptions of plants, all the knowledge, and use AI machine learning to do the classification. You can actually have a classification, and that can be put onto an app for traditional healers to use. By simply putting your plant in there, and it'll classify the plant, but not in English, right? It's going to classify according to a traditional knowledge system. Okay, and that's where you need Vukosi, to actually translate that into a language. And that would be a very useful tool for traditional healers to be able to use in the daily use.
Yes, indeed, and that's exactly what the Indians and Chinese have done. Now, you saying that it will be easier for us to then fast track using AI and big data through product development to then industrialization and commercialization. But the question is, if AI will be the one that is selecting the best plants, for example, or suggesting the best combinations, how do we deal with beneficiation? Who will own this knowledge which AI would have assisted us in generating?
You've put me in the corner, right? Okay, so ultimately, if AI is actually using the knowledge as well, the knowledge is always going to, you can always source where the knowledge came from, if it is also going to be using that knowledge. So the AI models are not solely based on just the chemistry or the biology. It is also going to be based on the knowledge itself. So the knowledge is embedded into the AI models as well. So you could always go back and source where it comes from.
That settles my heart. Dr. Cho, I was told that you are into precision agriculture. Again, I guess these things are related to all these emerging sciences. In one of the panels, one of our colleagues from the Agricultural Research Council, after all the scientists spoke that are responsible for the other fields, he said, actually, this is where we start. Even though I'm the last one, actually, this is where we start. What is precision agriculture, and how can it help us fast track, take a quantum leap into industrialization, and what capabilities do we have as South Africa or as the CSIR to then move towards industrialization? You'll realize that I'm very insistent on industrialization. Please go ahead.
Thank you, Mr. Moderator. My name again is Moses Azong Tse. That very short surname is pronounced Tse. I lead a group at the CSIR called the Precision Agriculture Research Group. We sit within the Advanced Agriculture and Food Cluster, one of the 9 clusters of the CSIR. I'm also a professor, the extraordinary professor at the University of Pretoria. And I am a remote sensing scientist, and majority of the colleagues in my group are remote sensing scientists. We are basically remote sensing data analysts. We look at images acquired from satellite platforms, from aircrafts or your drone systems, and even in situ based sensors. And we interpret the data. The data comes, is collected in several electromagnetic wave channels, and forms patterns, and we have to interpret those patterns, again using machine learning, basically, to get, or extract information from the imagery. And when it comes to the application of it, I would look at it in 2 points here. the very first thing is we can map the presence of different kinds of, different varieties of plants and plant species across the country. We've generated maps of the different tree species in the largest indigenous forest patch in KwaZulu-Natal, the coast, the Duku Forest, along the coastal belt of the province. And if you would visit that area, that small patch of forest, which we are pleading that we should really protect it, is very rich in biodiversity, and so many medicinal plants are present in that particular forest. If you would visit Tuba local market, you'll find all kinds of barks and leaves all extracted from that forest. And so what we can do is we can help the community to map the distribution of plant species in the country. I think that would be a very rich database to have, so that we have an understanding of the abundance of whatever feedstock that is available for different medicinal uses. So that's the first thing. So we can assist the community in characterizing or mapping or quantifying the abundance of indigenous plants in the country. And we've done that even across many other countries on the African continent. I always argue that if you don't know what is in your backyard, and our counterparts in the West use their technology and assess what you have, they would come in different ways to extract it, and we would still be under some kind of colonial power. So we need to invest in this remote sensing infrastructure, the satellite, the platform, to be able to assess what we have so that we take advantage of it before others come in. And then number two, with the same set of technologies, with images from your drones, from the satellite, we, as you mentioned, Mr. Moderator, we form the base of the food, of the agri-food chain. So we provide information that is then relevant to cultivation of crops and different plants. And I would say this is very critical because most of our tradi practitioners are harvesting the medicinal plants from the wild. And I think for us to then scale to ensure we can produce at commercial level, we have to then cultivate these plants. And some of them require very strict soil and other environmental conditions. So the first thing is, with our technology, we can map suitable areas for these plants where you can grow them. And using the same set of technology, we can monitor the cultivation from when it is planted to when it is ripe for harvesting. With remote sensing technology, you can even predict the biochemistry of the plants. Your secondary metabolites, your flavonoids and carotenoids, we can characterize them using sensors. And so we can even pick up the time of the season when these compounds are expressing themselves in the plants. And as we know, some of these plants express these compounds when they are being attacked by insects and so forth. And so your remote sensing technology can even pick up those time points in the year, and would advise you on when to harvest to reap the maximum sort of benefit from the active, bioactive compounds. So remote sensing technology, both for mapping, of quantifying the abundance of the plants and the rare species we have in the country, and also to assist in precision cultivation. And I think these two things can really speed up commercialization and scaling up of our IKKS products. Thanks.
That's really wonderful. This is wonderful because these are the capabilities that we have as South Africa. Now, we heard that we are facing, a myriad of polycrisis. and one of them is, of course, climate change, which is leading to like really crucial biodiversity loss. Can remote sensing assist us with making sure that we know how to maybe mitigate for these challenges?
Thanks. I think a very important question. We are living what we call global change, erratic behavior of our climate systems. And this is affecting the way our people interact with the environment. I think what remote sensing does, I think if you look at some of the popular satellites that are available and providing data to us for Mahala, for free, you find the European Space Agency constellation, the Sentinel, the sensor passes over every spot on Earth every 5 days. And so with that, you can basically, on a weekly basis, provide information on the changing conditions of your soils and your crops. And so that information would help growers adapt to the negative impacts of climate change. I think that is very critical. And we, our group, we do build monitoring systems for exactly that, for both your natural landscapes and your agricultural landscapes. Thanks.
Thank you so much, sir. Bolutendo, the two of you and Professor Madieke, you are in the same field. Is the field of nanotechnology.
Yes.
Maybe if you just enlighten us a little bit, what is nanotechnology, and how are you using it, if you are at all, in relation to indigenous knowledge systems in Limpopo? And do you think we have got the capabilities to start thinking about industrialization of the work that yourselves and Prof. Madieke are doing in nanotechnology? Or as a country, are we ready to use nano and IK for industrialization?
All right, thank you, Chair. Let me respect everyone. I am Rutendo Matum from the University of Venda. I work with bionanotech and drug discovery. I lead the group, research group on bionanotech and drug discovery. I work with medicinal chemistry the most. But before we could get into medicinal chemistry, we had discovered IKS. So we've been working with IKS. We were not even aware, because we were not at that stage of actually seeing that the people who are giving us information are actually giving us information that they hold, and they should also get something out of it. All right? So we have projects that span as far as working with 50 traditional healers at a go, which is very difficult to get information from them. As a scientist, you are seen as someone who is just there to steal information, and whenever there's a benefit, maybe you will run away. So it's very difficult to get IK-based information from the traditional healers as such. But yes, to your question, we do think that nanotech is ready. It's ready to serve the country. In the science that we do, the testings that we do, because we start in medicinal chemistry, we start with profiling. We start by profiling the compounds from all the trees, either from their leaves, the roots, the barks, whichever one that the IK holders would advise us that this is where you will find certain compounds. We will do the profiling. But we are moving from there because we already know, we have tested this. I will give an example of antioxidant activity, for instance, not to be too technical. When you have that already, you know that it's against certain molecules, it's against some scavenging in the system, or maybe antimicrobial resistance, for instance. We know where our profiled chemicals, how far they go. So we are bringing in nanotechnology to enhance that, to go beyond what we already know or what is already known. And at the same time, we are discovering the drugs that the country so much need.
Do we have examples of any of your formulations that are ready for maybe clinical trials as yet? Or are you still working on that?
We're still working on that. We're still working on that. We have formulations that are in our laboratories. We have not taken them out to any sort of testing. So we're still working in vitro. In the lab, we would test, we would see that they work. Antimicrobial resistance, we've seen that. Anti-cancer, we've seen preliminary results on the nanotech formulations that we have. But we have not taken them out to clinical trials and as such, commercialization maybe. And you would know some of the challenges we have on that will probably be funding, as you might know.
Thank you. Prof, you are maybe the one person that I know the longest that have been in this space. And actually, Professor Madiei was my mentor at the University of the North, which is the University of Limpopo today. You have been in this space for a long time and pioneering a lot of sciences that some of them are emerging from here in the country. What is green nano biotechnology? And how does it differ from the other nano, maybe the nano that Dr. Lutendo is talking about? And what are the capabilities that we have as a country? And again, the same question. How far are we from industrializing based on green nano biotechnology? It's a very long word. Please.
Thank you very much for the opportunity, Dr. Chabalala. Yes, you and I come a long way. As he indicated, so my name is Professor Abraham Madiei. I am the head of Nano Biotechnology Research Group in the Department of Biotechnology at the University of the Western Cape. I am the Deputy Director, or I was the Deputy Director of the former Nanotechnology Innovation Center Biolabels Unit of the MinTech DSI NIC. And currently I am the Deputy Director of the DSTI TIA nanotechnology platform. As everybody has been indicating, the knowledge of medicinal plants we get from our grandparents, especially for me. My grandfather used to take me around and insisting that I should know the value of traditional medicines. I always said he had very good echolocating skills for the medicinal plants. And I want to fast forward that because as I was preparing for this, I said, wouldn't it be prudent out of this summit that something similar to what Prof has just indicated is formulated, where we can use AI for echolocation of all the medicinal plants in the various provinces, because that will assist us to understand the impact of climate change, to understand biopiracy, and to understand issues that of, for example, overharvesting of medicinal plants. So I'm glad that he raised those very interesting tools that could be used for this. Now, my interest in IKS, when I came back from my PhD days, I wanted to study how we can use indigenous medicinal plants of South Africa for the treatment of stress. Because in my PhD, I understood the impact of stress on the development of obesity. right? So I started working on that. We worked on systems, we understood. Now, how glad am I that this summit is happening? I went to Ankh and I said, bro, can't we interface nanotechnology with IKS? Can I take medicinal plants and apply nanotechnological ways to deliver them? So in this case, it would have been encapsulate the medicinal things that it will be easy because the challenge is with bioavailability. It will then be easy for people to take. You'll take away the bitterness of the medicine. You'll deal with all sorts of things. More importantly, I said, we can also develop precision, targeted drug delivery systems. And fast forward, a dream denied is not a dream deferred, right? So in this particular case, I deferred my dream. But when I went back to the University of the Western Cape, you know where else I've been. When I went back to head this group, I asked for a dispensation from the Department of Science and Technology to say, because you want us to beneficiate gold, so we would like to do nanotechnology-based gold systems for the treatment of obesity. Fast forward, that work is published. Second to that, we are busy with patents, but the carrier is not patented. What is patented is the medicinal component of this. So then we come to COVID. COVID-19, earlier you heard Mr. Khomeswana raising the issue of Lingana, Artemisia afra, and wanting to know why didn't South Africa do anything about it. I'm not going to tell you why, but all I said was South Africa was already positioning itself to help Mauritius through the CSIR to commercialize Artemisia afra. When Lingana is used by any, Lingana umhlonyane and all of that for the other people. So you can see also that that cohesion is not there when it comes to IKS. You are prepared to help somebody else, but not help your own to develop these medicines. Now fast forward this to the University of the Western Cape. COVID comes, we go to DSI and say, we can develop something as an antimicrobial or as an antibacterial during the time of the pandemic. DSI say, prove it. So we say, put money down and let's see. They put money down. And first of all, we started, the first thing, as we know about COVID, was hygiene, wash your hands, do. So the first thing that came was, let's develop a bacterial soap that we can then put in various places for washing. We did that. And again, as everybody was saying even yesterday, thanks to the DSTI funding that we received, unlike my colleague, we have advanced that nanotechnology-based soap to the next level. So it went through testing in terms of safety, in terms of skin patch, to see that it doesn't cause irritation on the skin, to see. So we had 4 products: the soap, the lotion, the creams, and the face wash. These have gone through testing, and 5 SMMEs are currently in the process of commercializing those products. And so at this present moment, I just received correspondence that they will be going into custom manufacturing from the week. So they are now going to start with the, as you know, it's 4 SKUs, and they are going to have 400 each. So we are now, they are going to have 100 per product, so it's 400 times 5. So we have 5 companies as proof that this is commercially viable and so on. And what do we have at the University of the Western Cape? Yes, this was not easy. I must say to everybody, as long as we keep doing research and development without somebody from the commercial space, it's going to be difficult to commercialize. So what helped us here was that we got a consultant who then came in and showed and took over project management from the commercial end of that project. Thank you.
Thank you so much. I would have liked to take many questions. Maybe we can take 2 or 3 questions before the next panel starts. Do we have any hands? I see someone in a white jacket. Please go ahead whilst we're looking for another hand. And also mention who you're directing your question to. Please go ahead.
Thank you. My name is Mpho Baloyi. I'm a master's candidate from University of Pretoria. My question is related to Prof. Prof. Moses Cho, in regarding to precision agriculture. I think we have an understanding in this room that indigenous communities have been using things like tree phenology, animal behavior for rain prediction per se. So how then do we take use of this indigenous knowledge to leverage on agricultural, precision agriculture to ensure that smallholders understand how these technologies work and how they can integrate with their indigenous knowledge systems like a tree phenology on how they observe certain changes in particular trees, indigenous trees, and also animals, in them understanding and predicting weather changes, which helps them to select certain types of crops to plant based on the type of weather change or season that they are predicting. So and then also my question, it also relates to, in terms of using this agricultural precision technologies, what are the skills development programs to ensure that indigenous communities are able to access this information and be also interpret this information? I think, I'm not sure, but I once on your study with UP, you indicated that about 95% of smallholder farmers do not have access to these satellite information that they can use to make decisions about their farming. My second question also it goes to about data sovereignty, but it's not related to Prof. Cho. I forgot, I didn't note the name here. So it is good that we are excited and enthusiastic about AI and big data. But my question, the question about data sovereignty remains concerned, and that's where my question is to say, how do we, what are the frameworks that are there to protect data sovereignty of indigenous holders, and also to ensure that their agency as knowledge holders, it's not disrupted? Thank you very much.
Thank you. Dr. Tse first, and then any of you can then respond to the second question, and then we'll then close. Thank you.
No, thanks for the question. Very interesting questions there. I think, your satellites and your drones, I would just call these things tools. These are tools that are then, just like your laptop or your computer, you have to use it in conjunction with something else, okay? If some of the platforms we've developed, if you go into those platforms, we would advise the user that this information is generated from satellite. Use your experience and knowledge and wisdom in combination with the information that you get from those tools and make decisions about your farming process. So the indigenous knowledge on the tree phenology and how your landscape changes with season is very important. But mark you that with this erratic behavior of the climate, it's now confusing our indigenous knowledge holders. Our farmers are confused as to when they should plant, for example, because in previous times or in former times, we knew that maybe by the second week of October in the summer rainfall region of the country, we'll have the first rains. But this year, for example, El Nino a drought period is being predicted. We cannot tell when the first rains will come. Maybe in November, maybe in December, like we had in 2015. So it's a combination of the knowledge, existing knowledge in the region, and what these tools are providing, both your climate modeling systems and so forth. A combination of this should help our farmers and users across the agri value chain. When it comes to data access, I think our counterparts in Europe and in the US, they've done quite a good thing to provide the satellite data to us for free. And what we are doing is adding value to that data. And I don't expect our tradi practitioners, our traditional doctors and farmers and small-scale farmers to go use a computer and start interpreting satellite image. I think that's where we are encouraging our young graduates and diplomas. Please, you guys are very skilled in building applications, mobile apps, and this. Build applications that can simply transmit this data to your mother, to your father, to your granny in the village. Maybe a simple WhatsApp message to say your soils are acidic, your soils are lacking compost. You need to apply compost, you need to apply biochar to reduce the acidity. And that information can make a big difference. We've seen farmers improve their soil acidity and grow, for example, their maize production from 3 tons per hectare to about 8 tons per hectare by just correcting for the soil pH. So the farmer doesn't need to know what is happening behind the scene with the satellites and all of that. Just let's help them with systems that give them data on their simple devices. Thanks, I will end there.
Thank you so much. But maybe in short, data sovereignty, any takers?
Yeah. On data sovereignty and AI sovereignty now that we're calling it, it's really going to be with instruments that can then be used. So on one part, remember, even whether it's DSTI, NRF, we have a very big push for open science. But then this must also be tempered with that part of saying people would like to have control over how things might be used or who beneficiates. It's not just a thing of giving away everything. And that's why I gave the example of some of the work that's happening on equitable licensing, right? It's providing other options. In some ways, if somebody was asking, what should I do if I'm releasing data about my area? And I would really like to keep it that people are sharing in a way that really benefits our society. I would almost say use a Creative Commons attribution share alike. What this means is that people have to attribute that they got this data from you, but at the same time, anything that they build and create more data, they must share it in the same way. So this is almost like, if I've made my data available to you so that you can use, when you take and you create something with the same data, you must share the same way. Right? This gives, you are being very clear. And a lot of people don't understand what licensing means. They think if I upload a file and I put it online, it means that it's open and people can. No, it's not. If you don't have a license, it's closed. People just say, I won't touch it. And as such, you think you're sharing knowledge, but you're not. At the same time, yes, there are other licenses like a CC0, which just says, no, it's free, you can use it for whatever, you don't even need to say you got it from me. And if you build something, you can use whatever other licenses. These are all balanced and they require then the knowledge and people knowing how to use this. You can put another one, CC BY, NCSA. The NC says non-commercial. You can take the data, you must attribute it to me, you must share it in the same way, and you cannot use it for commercial purposes. These are things that are there, and then people then allow. Sure, they might require that you have good lawyers on the other side, but because people are not really understanding how to use these licenses, it feels like we don't have control.
Thank you so much.